and the experts and the information just keep coming at the Enterprise Integration Summit. We turn now to CData Software's CMO, Eric Madariaga. Eric, I want to welcome you to the show.
Thanks, Vance. Glad to be here.
We're glad to have Eric with us. He is one of the co-founders of CData Software and now leads the company's global marketing and strategy as well as execution. Previously, Eric led marketing and business development for N Software, one of today's leading developer tool companies. And we'll see in just a moment in his session that he has a passion about the intersection of marketing, technology, and data. And in fact, that leads me to his session, Embedded Data Virtualization, Universal Data Connectivity for Applications. All of us here today at the Enterprise Integration Summit know that integration continues to be a pervasive challenge, but it's also a linchpin for success. And this is especially true as IT continues to look for efficient and reliable ways to connect cloud, SaaS apps, and data. Today, Eric is going to help us add to our toolbox with a look at a new type of data virtualization, embedded data virtualization. You'll see how it's different from traditional data virtualization by the way it can simplify integration across disparate apps, data management systems, and ever-expanding hybrid infrastructures across on-prem and cloud. And just a quick reminder before I hand it to Eric, you can download his slides if you haven't already done so. I highly recommend it. Just hit that nice red button under the view screen. You'll also see Eric and his team have brought us some terrific white papers and other downloadable resources. They're available too without any extra registration. You did that to join us today. And if you have questions or comments, we're here. So just type in the submit a question box. We'll make sure Eric gets your comment. So with that, Eric, let me turn it back to you and tell us about embedded data virtualization.
Thanks again, Vance, and thanks to everybody for joining in today. As Vance mentioned, my name is Eric Madariaga. I'm one of the co-founders here at CData Software, currently run marketing for the organization. For you developers and architects out there, please don't let the marketing title turn you away. Spent over 20 years in the developer tool space and more hours writing code than I care to mention. My goal has always been to help developers build better applications faster. Today is no different. So today I'm going to talk to you about embedded data virtualization, what it is, where it's used, and how it's different. Taking a look at the agenda today, I'm going to start out giving you a brief introduction to CData. Then I'm going to talk about data fragmentation, what it is, and the unique challenges facing users in today's API-first economy. We'll drill into data virtualization, and we'll look at how the market thinks about data virtualization and how embedded data virtualization is different. Following that, we'll take a look at how we at CData think about those virtualization technologies and how we can help you apply those to your applications and solutions. And finally, we'll finish up with a brief Q&A where we can dig into any questions that you may have. So with that, let's get going. So to tell you a little bit about CData, we are a data connectivity company. We're a leading provider of data connectivity solutions to SaaS services, NoSQL databases, RDBMS systems, and pretty much any type of data that you use within your organization. Connectivity is essentially our core. We provide libraries that you can use to embed inside of your applications in order to facilitate integration with all kinds of different data sources, over 200 or so of these data sources to be exact. Taking a look at some of the strengths of our technology, we have, as I said, more than 200 or so different data sources that we support. These embedded adapter technologies integrate with every major application and technology from your current BI tools like Power BI or Excel to legacy tools, Crystal Reports or Oracle's data integration platforms or whatever it is. We simplify that data connectivity layer. And the way we do that is we provide a robust SQL engine. And that SQL engine basically transforms requests that your applications make into back-end code that integrates with these underlying data sources. And finally, our proprietary code generation framework helps us deliver these at scale. So we have a full-on matrix of data connectivity that starts with our ODBC layer all the way through to adapters for MuleSoft or Power BI or what have you. So what's the problem that we're trying to solve? As many of you know, data is becoming increasingly fragmented. SaaS applications, as they say, are eating the world. Something in the neighborhood of 58% of companies are running almost completely on SaaS applications, everything from their CRM systems to their ERP systems to your accounting packages. All those things are delivered through cloud services in some way. So this data is getting increasingly fragmented. Many analysts predict incredible growth within SaaS. By 2025, Network World's predicting that cloud environments will host nearly 50% of all enterprise data. So data is being increasingly distributed across SaaS services, and there's no longer a centralized system where people are connecting and integrating. The traditional RDBMS days are unfortunately long gone. So what does this look like? The long tail of data connectivity is incredibly long. So there's relational databases that are kind of the most consistently used data sources. There's SaaS applications, kind of the core SaaS applications that are powering enterprises, the Salesforce, the SAP, the data warehouses, other data lakes and things that people use within the organization. And there's the verticalized apps and services, things like your marketing automation platforms. And then finally, there are specialized and emerging technologies. And those technologies are expanding very rapidly. There's all kinds of new verticalized SaaS applications for CRM, for healthcare, for retail, for whatever it is. People are building these SaaS applications. And so you can see that data fragmentation is expanding tremendously. So the result, ultimately, is that data integration from an application perspective is going to continue to become more complex and more resource intensive. So how do we solve that problem? One of the more popular approaches is through data virtualization. Gartner estimates that nearly 60% of organizations will use some form of data virtualization by 2020. And why is that data virtualization important? Because it provides rapid time to solution, improved data quality by avoiding replication, and it delivers access to real-time data. All this happens by creating a virtual abstraction layer which provides live data access to the underlying data sources that it integrates with. So instead of having to move data around and doing things like ETL or doing things like data warehousing or what have you, you're accessing data in a live way through a virtual abstraction layer. So what is data virtualization? We kind of drilled into this in the previous slide. It's an approach to data management that allows applications to retrieve and manipulate data through that virtual layer. Predominantly what this means is you're creating a tabular interface, almost a relational interface on top of underlying data. And the components that make up data virtualization include a real-time data connectivity layer, query federation engine for accessing those multiple disparate sources, caching and query optimization, because if data retrieval is slow, whatever your application is not going to perform well, data transformation and custom views. This is how you model data after it's connected through this abstraction layer. Metadata discovery being the data about data. What is the underlying data that you're working with and connecting to? And then data consumption layer, where you can go out and connect to all the underlying disparate data sources that power your business. So when you look at a typical data virtualization architecture, this is really what it looks like. People talk about data virtualization commonly as an application that you install inside of your organization, and then all of your enterprise applications, all of your reporting, your BI, your web applications, everything works through a data virtualization layer to access all of the disparate sources within your organization. It's a very popular model, and it's an important model, and we think it's very valuable for organizations. However, there are some issues with having a large data virtualization layer. So when we talk about embedded data virtualization, what do we mean? So embedded data virtualization is leveraging the same technology, the same virtualization technology within data integration tools, within data warehouses or DBMS systems, or within things like iPaaS applications. So data virtualization has become such a popular capability that it's now being embedded in these types of solutions. So as a data warehouse, say that you're a data warehouse that's aggregating all of an organization's data warehouse may want to embed connectivity within the data warehouse itself for pulling data from disparate sources and providing a data virtualization layer inside of the application. So when I talked about the difference between corporate IT setup standalone data virtualization platform and an embedded data virtualization solution, basically IT drives the standalone data virtualization solution. you need to have a significant IT investment in order to set up and configure data virtualization. There's a high cost of licensing, and there are large support fees. At the same token, from an embedded standpoint, the embedded capabilities are more tactical. They can be deployed within a solution, within individual solutions, and distributed throughout your organization. So instead of having one point of access to all of your underlying data, each application can control how it works with the data sources that it connects to. And so how do we get there? How do we offer capabilities for embedded data virtualization? The first step from our perspective is to provide a SQL abstraction layer for the underlying data sources that we work with. We do that through our driver technologies, through our ODBC drivers or ADO.NET drivers or JDBC libraries. And really, they're designed for data-centric applications. If you want to connect to Salesforce from a BI tool, you can use our ODBC driver and embed that in your BI tool and have access to Salesforce and all the underlying metadata and capabilities that are available within that platform. And so these cover a large majority of the data virtualization components that you would want within your applications. And when we talk about the types of data sources, as I mentioned, from our perspective, we cover a huge number of different types of data connectivity, from NoSQL and big data and RDBMS to accounting packages, CRM solutions, ERP solutions. We provide a SQL interface for connecting to and working with data from any of these solutions. So basically, from a developer standpoint, you have one integration point, one common API for working with data from any of these solutions. You think about the types of products and solutions that are working with data from disparate sources. These are the markets really where embedded data virtualization technology is really important. So in BI and analytics is an obvious choice. If you want to connect to data, you first need to have access to the underlying data sources that are available. At the same token, data integration, data governance, data warehousing, data preparation, all of those data-centric, data-heavy platforms need the ability to interact with their customers' data, wherever that data is. And so some of our partners are leveraging this technology in order to provide that capability for their customers. So to drill in just a little bit about how this works, this is an example, as I mentioned, using our ADO.NET data provider within Microsoft Visual Studio. We model everything from the underlying APIs through a SQL interface. So when I work with my Salesforce instance, I can connect to Salesforce, query all of the tables of data that could potentially be available, and then run full CRUD operations on that data. So I can select everything from my accounts, use a complex filtering and push down capabilities, and integrate with Salesforce without ever having to write to their own API. I have the ODBC interface. I treat everything just like a database when doing that connectivity. And so to give you kind of an example from a pure developer perspective, dropping into code, this is exactly what it would look like when integrating with a technology like Salesforce. We support selects, we support aggregate functions, the ability to read, write, and update data. All of this can happen through the same way that you would interface with a database like MySQL or SQL Server, Postgres, or whatever it is. They have full support for joins, updates, aggregation, and everything else. Now, what do you need in order to make this possible? So from a connector layer, simple connectivity is not going to work. Our SQL engine, our drivers are incredibly robust. And that's the only way that we're able to provide that type of SQL interface to the underlying data sources that we work with. So essentially what we do is we provide a full SQL 92 engine within every driver technology that we have, full metadata discovery, string date numeric functions, and then push down capabilities within the drivers themselves. So as we mentioned before, performance optimization is incredibly important. All of this kind of goes into the intelligence part of building a driver and building that connectivity to the underlying data sources that we work with. So the connectors themselves couldn't possibly be limited connectivity to the individual data sources. Instead, they have to have the SQL engine in order to support the full breadth of tooling that's going to integrate with those APIs. To give you an example of the power of SQL and SQL abstraction, we look at one of the case studies that we have from one of our partners, and this is Bouquet.ai. Bouquet.ai is unique. They're a machine natural language processing product, which will take questions in natural language and send them back to your database to help you find answers. So for example, what's the win rate for all of the opportunities within my industry? And so their platform will package that up and send that to your database, and then you return data that way traditionally. And so when they came to us, they were interested in extending their product with SaaS connectivity capabilities. They wanted to integrate with, I think, Salesforce Einstein. There'd be absolutely no way to do this without a SQL abstraction in between their product, their AI, ML, natural language processing product, and Salesforce Einstein. It would be impossible to write code that would make this work. Instead, what they were able to do is take our drivers, drop them into their solution, and we could consume the same queries that they were sending to the database to find information, and would reply with data directly from Salesforce Einstein. So it's a really interesting use case for machine learning and how that works with kind of that SQL abstraction layer. So taking things a step further and going in a little bit more to the data virtualization capabilities, something new that we're releasing fixes that last piece on the embedded data virtualization slide, and that is a query federation. So the individual drivers themselves work by abstracting connectivity to the underlying APIs they support. But what they did not support is federated queries, and that's the ability to join data live between data sources. And so our new data virtualization driver helps solve this situation. What it is it's essentially a driver of drivers. You have a driver and adapter layer that you can embed inside of your application and then install one or more individual drivers. So Salesforce and Excel and SQL and MySQL and whatever else it is. And now you can do things like live joins across data sources. So I can integrate things in a live manner and truly provide a data virtualization experience to my customers. So as an example, as I mentioned, sample integration would be Salesforce and Excel. You have a list of data, customers within Salesforce, and then some additional account information within a local Excel sheet, and you want to be able to join that information without moving it in a live fashion. So you would write a query that would connect across both Salesforce, in this case Salesforce DB, although it's a virtual database, and the result, in this case, what we do is we visualize that data in DB Visualizer, although it could be embedded inside of any solution that you choose. And so this is the next evolution of embedded data virtualization, and it shows how we can fully provide that kind of data connectivity to applications like data integration platforms, data warehousing, or other iPaaS type products. And so what are the advantages of SQL and this tabular interface for doing data integration? One, the tables themselves are self-describing. So as a developer, as I said, developer productivity is something that we focus on a lot. There's no need to dig into API documentation or dig into how to work with these underlying data sources. The tables are generally self-describing. You can plug in our driver, query the driver for metadata and for the underlying data, and automatically be integrated with that underlying data source without having to do any complex software development. And that leads to rapid data integration and application development. The other thing that's interesting is that we abstract that data layer, and that really insulates developers from underlying API changes. And this happens quite often. If an application or a SaaS service like Facebook or Salesforce or what have you, they update their APIs, their security changes, security regulations, or other things. All we have to do is ship a customer a new driver. So that SQL abstraction layer still provides that same interface for working with the underlying APIs and working with that underlying API data without having to recode, retool, update other pieces within your application. And so finally, kind of as the main takeaways, when you look at data virtualization and data integration, I would encourage you to choose an integration technology based on your current and future use cases. So when you're looking at data integration, you want to not just be concerned about getting together that POC for a customer, but also how am I going to be able to support the evolution of that POC into a fully productized solution? What's going to happen in the future when APIs change and I have to go in and manage that underlying integration? Also, if your solution, if your product has the capability to support citizen analysts or integrators or other types of third-party tooling, you should take that into consideration. SQL abstraction is a fantastic way to support those users because they don't need to know any of the integration details of the underlying technology. And then really explore a data-centric integration based on those types of established standards, as one-off integration with APIs truly doesn't scale. So if you're part of an integration team and you need to build out dozens of integrations with other APIs and applications, which, as we mentioned from earlier, is really a pervasive challenge, having an abstract layer that simplifies that process, whether it be embedded data virtualization or even just direct SQL connectivity to those data sources, is really the only way to be able to extend your platform connectivity in a way that's scalable for the future. And so with that, I'd like to turn it over for questions and see if there's anything else that we can answer for you about the slides or how we can help.
Eric, fantastic overview of a really innovative technology and some terrific use cases. I'm sure that many of our attendees that the wheels are turning inside their heads. So thanks for a great session.
Appreciate it. Thank you.
Eric, lots of different directions to go in on this, just to help people get a mind map of how you have architected data virtualization, especially as what you say, a layer inside the application. Let me ask this general stage setting question. It sounds like that under the covers, thanks to the CData software interfaces and drivers, that your goal is to give the app and data person a familiar SQL interface, so to speak, to the way they can access the information they need. Is there anything close to true about that?
Absolutely. That's exactly right. And the reason for that is kind of unique. It's that most applications that exist today already know how to speak SQL, right? So BI tools, data integration tools, ETL tools, any data-centric application that exists today already has the capability and the facility to work with data through SQL. So there's no additional programming or coding or anything else involved with integration through this SQL layer. This capability doesn't have to be a huge corporate IT investment. This can be a component of a web application. This can be a component of your integration solution internally. It's basically a component of an application or solution instead of really a standalone product. We like to think of it in the context of how we relate embedded data virtualization and data virtualization to how the market thinks about BI and embedded BI. One is a standalone solution, BI, it's your Power BIs, it's your Tableaus and whatnot. And the other is embedded BI, BI that can be embedded inside of applications and distributed throughout an organization.
Yeah, it's a really, really intriguing and rich approach to a very pervasive problem. So as you might expect, I got a couple of drill down how-to and technical questions. We've got a pretty technical, skilled integration audience here. The first one, a lot of folks think of SQL as being in favor of structured. How do you handle data sources that are non-relational or hierarchical, such as JSON or NoSQL?
Yeah, absolutely. That's a great question. Essentially what happens is that the driver layer, we offer multiple different ways to flatten and look at hierarchical data as a tabular relational type structure. You can take hierarchical data and model it as a set of tables, which the driver can handle automatically with joins across tables, or you can fully flatten out that hierarchical data, or you can even process structures client side at runtime as well. So there's a bunch of different ways to do that. We actually have some additional details and white papers I think we're attaching as one of the resources to this presentation.
Excellent. And in fact, as you described that, Eric, it sounds to me that this sort of use case with structural and non-relational would be a perfect example of your latest federated query feature.
Yeah, that's right. I mean, that way it can work across any type of underlying data source, everything from the databases that provide JSON object store returns to those individual APIs that we work with as well.
Another theme here that goes hand in hand with data updates and synchronization is the idea, okay, we got target and source, but they basically can be bidirectional. So the question says, can CData software be used to both read and write back to the data sources?
Yeah, it's a great question. And so in the context of the drivers themselves, the driver connectivity layer that we provide, the ODBC drivers and JDBC drivers, those are fully bidirectional for any data source that supports it. Obviously, writing back to something like an RSS feed as a data source wouldn't work. Now, to abstract that again and actually have the federated query engine above that, that's where things would be difficult because you'd have an abstracted virtualized view on top of a cross-joined source, and that would make it very hard to do writes. So if you needed to do writes back to the underlying data sources, I would encourage using the drivers instead.
And the connections, Eric, let's drill down on this theme a little bit more. It's a really good one. Are these ongoing? You gave that great example of Microsoft and Salesforce. When one endpoint has an update, say 14 days after the original connection or integration might have been made, what's your best practice for that?
Sure. So as a company, it's our job to maintain those integrations and those interfaces with all of the data sources that we support. And so if an application rolls out a new API or a change in security feature, we take on the burden of doing that maintenance, doing those updates, and then what we deploy are drivers or deliverables to our customers who can then swap out the driver that they currently have and then continue to work with the underlying APIs without having to do any changes to their underlying applications. At the point of issuing that query, you're getting live data from the underlying data source that you're working with, right? So when we update a driver and we swap out a new driver, that driver is still going to work with that new query that you're submitting to that underlying data source. So every time that you query it, you're getting live data from whatever API that you're working with.
Excellent, excellent. Eric, this is fantastic. Just to kind of talk about implementation just a little bit and who would do it, it seems that there has to be some preparation going on, either with the app itself or the data sources that I'm going to communicate with through CData software. How does that get set up and who does it?
Sure, absolutely. So if you're looking to do integration with an application, and when I say an application, I mean an application that your company develops and builds, then you're definitely going to need developer support to do that kind of integration. However, each one of the form factors of our drivers work out of the box. So you can download from our website one of our JDBC drivers or ODBC drivers, plug it into whatever BI or ETL tool you use today, and they can work with the underlying data sources that we support without really doing any kind of setup or configuration. I mean, you basically point that driver at whatever the data source is, configure the authentication with your username and password credentials, and now you can interact with Gmail or your contacts or whatever else it is directly from whatever application.
Fantastic. So many different possibilities for where I can use embedded data virtualization. The question comes in, where would the technology embedded data virtualization not be a good choice?
That's really a good question. So, as I mentioned, data virtualization here is talking about kind of a request response pull method of pulling data from underlying data sources. So in some instances that everything is much more transactional. If you needed to work with a message queue or something to that extent, it might not make sense or it might not be easy to connect embedded data virtualization to those data sources. But predominantly when you're looking for that type of data integration solution, you're really looking at data-centric applications that are providing accounts data or data from your ERP or things like that, or your database or data warehouse. And that's where really that embedded data virtualization capabilities, they really shine.
Fantastic. Fantastic. Eric, this has been a fantastic session, a really high energy Q&A. I see we're just about out of time, but before you go, give us a sense of how folks could learn more about CData software, maybe take a look at some of the patterns or the technology of your drivers, or just overall go deeper.
Yeah, absolutely. So we offer fully functional free trials of everything that we provide available online. So customers can come to our website, www.cdata.com, go into the individual technology that they're interested in using, like Power BI or ODBC or JDBC or what have you, and just download the product and start working.
Eric Madariaga, CMO and Co-Founder of CData Software, a fantastic session, and thanks very much for taking us through some very innovative new thinking and technology for integration, and especially for a Q&A that really shed some more light on your approach. Appreciate it.
Thanks very much, Vance. It's been great.
Yeah, and we've enjoyed having you too. And just a quick reminder, Eric's left some terrific assets in the room here just under the view screen. You'll see some of his great downloads. You'll see a copy of his slide deck, which I'm sure now that you've seen what's going on with embedded data virtualization, you want to take a closer look at, and including that free trial, speaking of a closer look. And so much going on at CData that we didn't have room for everything. So here's a slide that'll take you directly to their website. Download Eric's slides, and these links will all be live. Thanks again, everyone.